Hello everyone, welcome back to the video lectures on image and speech processing. So we have been discussing about the image compression model techniques and various lossless compression models like Halfman coding, Shannon-Fannon coding, right? So in today's class we'll be talking about LZW coding, right? So what kind of an coding technique it is? A lossless. It is a lossless, right? So this is another coding technique which is lossless. In our previous lectures we have talked about Halfman coding, Shannon-Fannon coding, right? Then we talked about in our previous arithmetic coding, right? Arithmetic coding. So all three are other types of the lossless coding techniques. But if you observe clearly, we have all talked about here, these three are variable length, right? So these are the variable length coding techniques and they are used for reducing the coding redundancy. Whereas LZW is used for reducing the spatial redundancy. Right? How is this achieved? We will see in this video. Right? So what is this LZW? It is an error-free compression that addresses the spatial redundancies in the image. Next, it was developed by Lempel Z. Welch coding. Okay, that is why we are calling it as LZW coding technique. What are we doing in this coding technique is assign fixed length code words to variable length sequence of the core symbols, right? So if you observe here, it is the fixed length code word, whereas the sequence what we are considering is the variable, right? In our previous coding techniques, we have used variable length coding word for fixed sequence. So this is the difference between the LZW as well as our previously discussed coding techniques. So because of this concept, where we are using fixed length coding for variable sequence, we are able to reduce our spatial redundancy in our image, right? This code doesn't require probability of occurrence, right? So what does that mean? We need not require to know how many pixels are there and how many pixels are having the intensity value R and so on and so forth. So this is a major advantage because many a times we might not know what are the pixel values. We might know what is the next pixel value that we are going to get, but not the whole image, right? So this is useful in such type of coding, such kind of applications. This coding is based on dictionary based coding, or it is dictionary based coding. So dictionary based coding is what are we doing is in the dictionary we are consisting of encode output for a single intensity value or a group of intensity values. So like how we have a dictionary in our English language, we have, say suppose in English dictionary we have the word letter A. So we have in the dictionary all the words which are starting with A, like ant, arrow, right? So what does this ant will have a specific meaning. So this is how a dictionary, English language dictionary was maintained, right? Similarly here we are also maintaining a dictionary where we have this is specific for a specific image, okay, right? We are having some intensity values, whether it is a single, it can be the intensity values can be single, or a group, it can be having a group, right? For that specific intensity values we are giving some encoded output, right? So how are we going to do? We will see in the form of an example. Okay, so before we go, let me talk about the steps how we are going to do this LZW coding. Now first we have to recognize the dictionary for a given image. So as I said, the dictionary is dependent upon an image. So first we have to recognize what is the dictionary. So what are the encoded output, possible encoded outputs, and what are the possible intensity values that might exist. How are we going to do that? See, if an image is 8-bit, then the possible intensity values are 0 to 255. How did we get this 0 to 255? It is 2 power 8. Right? So the dictionary values can have the encode output as 0 to 255. Right? Now, if we are using LZW coding, then what we do is we take, if it is an 8-bit image, we consider 9 bits. We consider 9 bits to code the intensity value. So what is that? If the possible intensity values can be represented by n bits, then for LZW code we use n plus 1 bits. Right? So here, as I said, if there are 8-bit, we will use 9 bits. So why are we using this? We will see in our example why we are going for 9 bits and all we will see in our example. Okay. Now, the other possible encode outputs are now since we have used n plus 1 number of bits, so what are the possible number of encoded outputs were 0 to 2 power n plus 1. Right? So if we are using 9 bits, then what are the possible number of bits that we can have? 0 to 5, 2 power 9, 2 power 9, which is equal to 0 to 515. Right? So many number of bit values we can have. So many number of encoded outputs we can have. Right? Now, we will create a table for an image and we will try to code. So what does the table contain? It will contain the intensity value from the image, previous pixel intensity value, encoded output, dictionary new entry. Okay, so what does this dictionary and new entry means? As I said, if we are using 8-bit image, then the possible number of intensity values are 0 to 255. So in LZW coding, what am I doing is, I am assuming that if intensity value is 0, I will code the value as 0. So intensity is 0, the coded output value will be 0. Right? If the intensity value is 212, okay, so what will be my coded value? It will be 212. Right? So that is why I have my dictionary as in this way, where it is intensity value, where the encoded output. If the intensity value is 0, 1, 2, so on till 255, I am saying my encoded value is 0, 1, so on till 255. So this is my coded dictionary table. Now, when we are using LZW coding, we are using 9 bits, right? So we are using 9 bits. If we are using LZW coding, instead of using 8 bits, we are now using 9 bits. So when we use 9 bits, we have the dictionary value from 0 to 515. So we have vacant places from 256 so on till 515. Yes. So this, the new dictionary value, whatever we have the vacant positions, that we can give as the dictionary new entry and dictionary. Okay. Let me just. So in this table, when we are creating the LZW coding, we will create a table such that intensity from the image, previously pixel intensity value, encoded output, dictionary as well as the dictionary new entry. Next, what we do initially what we considered is the previous intensity value is hyphen. Okay, for my first case, before if I just take my image, the intensity value before any coding technique, I will assume it in my hyphen or the first case, right? So next, consider the intensity value and place it in the first column of the table. So if I take the intensity value from my image, I will place it in this form, right? Say suppose it is 10, right? I have a hyphen in my first case and my first intensity value is 10. Now, if you observe here, the intensity value 10, it is already there in my dictionary. and it is already coded as 10. So if the intensity value is already coded in my dictionary, what do? I do not fill up this table. I do not do any modifications, right? So if the intensity from the image and previous intensity value combination, right, it's already existing in dictionary, then we do not perform any operation, or we do not perform any coding. So before, in the first case, if it is hyphen, right, so 10 hyphen combination is existing here, right? So that is why we don't perform anything. Next, what do we do? If the intensity from the image and my previous intensity value combination does not exist. So if that doesn't exist, so let me just go back. So here, say suppose instead of this 10 and hyphen, I have now as some 15, and my previous pixel intensity value is some 215. Okay, this combination of intensity value is not existing in our dictionary. Why? Because we have the dictionary values from 0 to 255. If the intensity values are 0 to 255, they are coded as 0 to 255. But 256 to so on, they are left vacant, which we are going to consider the new entries. So 15 combination 215 combination is not existing. So what do? We give them as, let me just, so we give this as dictionary new entry, and we write 15-215, right? And the dictionary value is the new coded encode output. So if now till 255 it is occupied, 256 is vacant, so I give my value as 256, right? What will be my encoded output? It will be my 215 value. Encoded output will be my 215 value, because it is the previous value which I have to encode, right? So this is how we do our LZW coding technique. So now, as I said, if the intensity from the images combination is not existing, then we encode in the previous intensity value and we give it in the new dictionary. So dictionary value will be vacant encode value from the dictionary table, whereas the new dictionary entry intensity value will be the combination of the intensity from the image and the intensity value, right? So as I said, 215 215, which is the combination of my intensity value and my previous pixel intensity value. This combination I'm giving it as the new dictionary entry, and the dictionary value, what are we going to write in my table? It will be the vacant encoded output, right? So that is how we are going to develop my dictionary. Right now, what are we doing? We are continuing the step 6 to 8 till all the intensity values of the image are encoded. Right. So this is how we perform our LZW. First, we develop our dictionary, and then we will try to take each and every pixel intensity values, and we will check whether it is already existing in our dictionary. If it is not existing, that combination with my previous pixel intensity values, I'm going to give it as a new dictionary entry, and we are going to give a new coded output, right? So let's see one small example and how this is happening, right? So if we observe here, this is an image of 39 126 39. I'm considering a 3 by 3 matrix, right? 126 126 39 26 39 126. So what are we going to do? We are going to first create our dictionary, right? So if we observe here, I have the number of possible intensity values are 126. So I will consider a 8-bit image for my convenience, or for this example I'm considering as 8-bit image. Okay, so now I have the number of possible intensity values as 0 1 2 so on till 255, right? Now, these are the possible intensity values. What will be my encoded output value? It will be same 0, 1, 2, so on till 255. Now, what am I doing? If I want to apply my LZW coding, I am going to use 9 bits, right? I'm going to use 9 bits to represent the same image right now. So what are the possible coding values? I'll have intensity values 256, 257, so on till 515. So the encoded output, what are those? sorry, this is the encode outputs are now 256, 257. I can have all such things. What is the intensity values which I have to do? I will take out from my pixel. I'll consider from my image. Okay, so let's draw the table. What are this? What is that? Okay, how to do the LZW coding. So we have the intensity value. We have the intensity value. Then we have the previous intensity value. Then we have the encode output. Then we have the dictionary. Then we have the dictionary new entry. Right? So this is our LZW coding. LZW coding table. Now, first case, when we are considering in my first case, my previous intensity value will be hyphen, right? So now I am going to consider my first intensity value, which is 39. Okay, so as we see from our dictionary, 39 intensity value is already existing in our here, which is coded as 39 which is coded as 39, right? So we need not do any operations here. So we are going to just leave it blank, right? Now, next we are going to consider my next intensity value, which is 126. Now, what is the previous intensity value that we have considered? That is now, instead of hyphen, we have 39, right? So, which is the previous condition, previous case, right? Now, if you observe here, what will be my encode output will be? It will be 39, right? So, that is my previous code value, right? So, what is this? I don't have the combination 129, 39 combination in my dictionary. So, what am I doing? I'm putting it as a new dictionary entry in my place at my vacant dictionary value. So, that is given by the 256 because till 255 it is already coded, right? So, 256 code value is left vacant. So, I'm giving it as for 256, I'm giving the dictionary entry as 126-39, right? Now, let's go further. So, what is this now? I have the next intensity value is 39, right? So, what is my previous intensity value that I have to consider is 126. So, that is written as 126. Now, do I have the combination of 39, 126? No. Why? I have the combination of 126-39 combination I have. I don't have the combination 39, 126. So, what will be my new dictionary entry will be now 39-126, right? Now, it can be placed at what place of my dictionary? We see that 257 is vacant. So, we have given the code value as 257. Now, what will be my encode output? It will be 126. Right? Now, continue. Let's continue. Now, what is the next intensity value that we have to consider? It is 126. Now, what is my previous intensity value that I have to consider? 39. If you observe here, 126-39 combination is already existing in our dictionary. It is already existing in our dictionary because we have coded in my second step here. So, what is the dictionary value? 256 encode output. 126-39 is already existing in our dictionary. So, what do? We do not perform any operation. So, it is left as it is. Now, next, what will be the new intensity value that I have to consider? This 126, right? So, that is given as, what will be my previous intensity will be now? It will be the combination of 126-39 because I have not coded anything. So, that will be 126-39, right? Now, what will be my encode output will be? It will be my previous intensity value, code value. So, I have to code my 126-39. So, what is that value? 126-39. What is my coded output? It is 256, right? Now, what will be my, since if you observe here, 126 minus 39 combination is not existing in my dictionary. So, I write it as my new dictionary entry as 126. I see that 126 hyphen 126 minus hyphen 39 combination is not existing. So I write it as my new dictionary entry. So 126 hyphen 126 hyphen 39. So what will be my dictionary value, which is my vacant? I have the vacant position at 258. Right? So this is how we go on. Next, if you observe, we have completed till this point. Next, if you observe, we have the 39 intensity value. So let me just go on. So I have the value 39. Now, what will be my previous intensity value that I have to consider here now? It will be 126, right? So my previous intensity value is 126. No, I have already, what will be my encode output will be, it will be my 126. Right? So my previous value will be, the encode output should be 126. Do I have the combination 39 126? It is already existing, so I need not perform this encode output. So I will leave it as it is. Now, next I will consider my next value, which is 39. Which is 126. Right? So now this is what is my previous intensity value combination is 39 hyphen 126. Right? So what will be my value? Encode output of value will be 39 126 encode output. So what is that value? We have given the dictionary value as 39 126 as 257. So I will write the encode output as 257. Right? Now, what will be my new dictionary? Do I have a new dictionary entry? Yes, I don't have the combination 126 hyphen 39 hyphen 126 in my dictionary. So I write it as 126 hyphen 39 hyphen 126. Right? So at what place do I have the vacant position as? I have it at 215. 258 is already occupied. So I will have my vacant position at 259. Right? Now, let's continue. So it's already coded. So next we have to consider my next intensity value. So what is that value now? Here is 39. 39, and I'm going to take my 126. Do I have this combination, which is my previous intensity value, right? So do I have this combination? Yes, I have this previous value. So now what do? I will not do any performance now. So what was this value now? What is the next intensity value that I have to consider? It is 126. What will be my previous intensity value? It will be 39 126. So if you observe here, do I have the combination 126 hyphen 39 126? Yes, I have. So I need not have any other, and I'm done with my number of pixels. So what will be the output I have to code is 126 hyphen 39 126 code intensity combination I have to code. So what is that value? Coded output value is 259. Right? So that is equal to now 259. Now we have done the coding technique. Everything is fine. Now how did we achieve the compression? So that is very unclear, right? So let me just tell that about. Say suppose I have the same pixel image which we have 39 126 39. So if I have to code, so what do? I'm using my 8-bit value, right? So I have 8-bit values. Now what am I saying? I have 9 pixels right here, 3 cross 3. So I have 3 cross 3, which will I have 9 total number of pixel values. So what I have, 1 pixel, I am representing it by 8 bits, right? So 9 pixels, how many pixels I require? 9 into 8, which is equal to 72 bits. Now let's observe this. So what is this? I have the combination 39. How do I code this? Code this image using LZW. I have to consider my encode output. This column I have to consider. That is equal to 39 126 256. So let me just write it using my LZW coding. If I have to use, how do I write it? using my LZW, how is my image coded as 39, 39, 126, 39, 126. Next, how am I coding it as 256, right? Next, I'm coding it as 257. Next, I'm coding it as 259, right? Now, each value is represented by 9 bits now. Using my LZW coding, I have to represent my intensity values by encode value using 9 bits. So each value is represented by 9 bits. So how many values that I have to code is 1, 1, 2, 3, 4, 5. Right? So I have 5 values which I have to code, and each value is given by 9 bits. So 9 cross 5, how many bits do I require? 45 bits. Right? So if I'm using normal 8-bit or fixed length coding technique, I'm going to use 72 bits. Okay, because each pixel value is represented by 8 bits, and if I have 9 pixel values or pixels, then I have to represent it by 72 bits. But whereas when we come for LZW, even though we are using 9 bits instead of 8 bits, the number of pixels or number of values which we have to code is much lesser than my original image value. So I'll have only 5 combinations where if each pixel each value is represented by 9 bits. Now I have 5 values, so I'll use only 45 bits. So this is how my compression is achieved, right? So this an example you can try where you can see that the combinations of the initial value is A, you'll have the combinations A, then you'll have the combination. So if you observe here, lot of spatial redundancy is achieved. What is the spatial redundancy? You have the combination A everywhere here, right? So because of my dictionary, this combination of A instead of using each single A using 8 bits or 5 bits, I can use this whole combination A and represent it by single bit, right? So I can reduce my spatial redundancy in this way. So what are the other possible redundancy I can have? I can have the combination AB, right? So this AB, BA. So all these combinations I can reduce using my spatial redundancy can be reduced using my LZW coding, right? So just for using 3x3 matrix, 3x3 image matrix, I was able to achieve compression of almost 15 bits, right? So if I'm using such kind of image, if I have such kind of image, I can achieve much spatial redundancy, right? So this can be further achieved. The same values I can reduce using my other coding techniques. I can further reduce it from 45 bits to further reduce it to 20 bits or 10 bits. So further I can go for my Huffman or Shannon-Farren coding to achieve further image compressions, right? So this is the how we will perform my LZW coding. So this is the reference that we are using, which is the Gonzalez book for my theory, right? So thank you.
Like, share and subscribe. Hit the bell icon for more updates.